And if you look at these images of somebody sitting too low, too high, and at the correct position in a workplace, the one on the left where they're sitting too low, you're going to get a lot of problems with your feet because you're not touching the floor properly or the footrest properly. And too low, you get a lot of problems in your neck, your top of your back, probably the shoulders and arms. Similarly, sitting too high, problems in your buttocks, your lower back, top of your back, your neck. The correct position on the right hand side is sitting with your back fully supported by the chair, bottom fully in chair, your feet supported by a footrest and on the floor, and your hands at right angles to the workplace, to the workstation or seating. Right, DSE, display screen equipment. Possible effects on health: work-related upper limb disorder, eye and eyesight defects, fatigue and stress. A DSE user is somebody who uses their equipment for the biggest part of the working shift. Perhaps in an 8-hour shift they are using it for 6 hours. An employer under those circumstances must carry out an ergonomic risk assessment, ensure the users take breaks, provide eye and eyesight tests for users if asked, and this is free for DSE users on the National Health Service, and to provide information, instruction and training. The environment: there must be adequate lighting without glare, cables must be safe, comfortable temperature, tidy desk, no noisy printers or other equipment. The keyboard must tilt slightly, be movable, allow room on desk for wrists, clearly marked and freely moving keys, and also to have these devices, which are wrist supports. Now they are filled with gel, usually, or sponge, and it prevents the wrist from pressing on a hard surface. Because if your wrist press on a hard surface for a period of time, it is a repetitive strain injury, as most of these are, you will, or you could get carpal tunnel syndrome, where the tube in the wrist crushes against the nerves in the wrist and causes some pain, inflammation, tenderness and loss of feeling in the fingertips. And the only way you can remedy that then is with an operation on the wrist or wrists. The screen should be directly in front of the user, top of screen at eye level. It should swivel and tilt, and there should be brightness and contrast controls. Posture: your bottom should be fully on chair, lower back supported by chair, feet on floor or footrest, and elbows at right angles. The chair: it must be a height adjustable seat, backrest to adjust a smaller back, it must be stable and have at least 5 caster wheels. Now these days it's very important from an ergonomic point of view that the job is measured to the person and not the other way around. Years ago, when I used to work in offices, we used to have a thing called hot desking, possibly 5 or 6 of us using the same desk and PC. These days that is not allowed. It's one person per their job, and that job must be fitted to that person. On work-related upper limb disorder, it's a repetitive strain injury caused by movements, twisting and force. Contributing factors include excessive workload, inadequate rest periods, sustained and constrained postures. Symptoms include local aching pain, tenderness, swelling and inflammation of the muscle tendon joint. Now, if an ergonomic risk assessment is carried out on you and your workstation, these are the sort of angles that are undertaken by an ergonomic risk assessor. It is quite a technical risk assessment. Manual handling. What is manual handling? It's the movement or support of any load by physical effort, including pushing, pulling, lifting, carrying, putting down, moving, and it includes using mechanical aids such as trucks and trolleys, because even with trucks and trolleys you are using your own muscles to mobilise the trucks and trolleys. Manual handling is the cause of the highest number of safety days lost to workers. Injuries account for over 1/3 of all reportable accidents at work. Remember I said at the beginning that the biggest cause of time off from work is poor manual handling. Biggest cause of injuries, slips, trips and falls. What types of injuries are caused by poor manual handling? Well, what do you think? Pause the presentation and write down as many types of injuries you can think of that are caused by poor manual handling. You might have had one or more of these: ruptured discs, sprained ligaments, sprained and inflamed tendons, muscular injuries, hernias, fractures, cuts and crushing. Manual handling. Now this is basically just a graphic rather, on how to carry an inanimate object, pick it up, carrying it. It's no substitute for a manual handling course, but it just gives you a basic idea of what or how you should approach an inanimate object. You need to assess the weight of item, decide whether you need help, decide where you're moving the item to, check the path is clear, check floor surfaces, push rather than pull. Only lift objects after you've carried out a risk assessment. If in doubt, ask your supervisor. Step 1. Stop and think. Position your feet in a balanced position. Step 2. Position your feet. Step 3. Bend your knees, and that's the crucial part of manual handling. You do not bend from the waist. Step 4. Get a firm grip. Keep the back straight. Step 5. Raise with the legs in one fluid movement. Don't make it too jerky. Step 6. Keep the load close to your body and make sure the load is at waist level. The easiest way is not necessarily the safest way. Try to avoid altogether if possible. Try to mechanize the task. Always risk assess before you attempt manual handling. Now, what do you think is the biggest problem with manual handling? What part of the body do you think is injured more by manual handling? Probably, as you guessed it, it's the back. And here's a pie chart showing you the different parts of the body that's affected by poor manual handling. 49% then, the biggest one, which is the back. Then you've got the fingers and thumbs. Then you've got the arm. 9%, that takes us on to the, I always get confused these colours, hand and wrist. Then the dark blue one, you got lower limb. You've got the rest of the torso and others, but certainly the back is the biggest problem. But why is that? Well, let's have a look at the back. We've got the human spine. Now, we've got different vertebrae. All these vertebrae are separate bones. You've got the cervical vertebrae towards the neck, that's attached, and that goes to the top end of the skull, bottom end of the skull, sorry, there. Then the thoracic vertebrae, the lumbar, down towards the lower part of your back. Now, between the vertebrae, you've got these, what looks like light green areas. These are the intervertebral discs, the shock absorbers. They prevent the individual vertebra from actually touching, because if they touch and grind against each other, you could get excruciating pain. Now, the spinal cord runs down the back of the spine, which is down there, contained in different processes which are there. Let's just show you that. So these are the individual vertebrae. There's an ordinary disc. Now this is what we call a slip disc, or rather what we should call a prolapse disc. It's actually pressing into the spinal cord. If you look at that at the bottom, it's not so much the spinal cord that's a problem with the slip disc, it's the spinal nerve that's coming from the cord itself. So in effect it is a trapped nerve, and the spinal nerve could be a motor neuron or any other neuron, and depending on where that spinal nerve is, depends on where you have the pain. If, for example, the spinal nerve, the spear trap's at the top of the back towards the cervical part of the vertebra, or the spinal column, then you're going to get pains in the top part of your back. If it's in the lumbar region, you're going to get pains in your buttocks and perhaps the tops of your legs. And just to show you that in a bit more detail, with A, on the left hand side, we've got a normal disc. We've got a vertebral disc. There's no pressure, there's no pressing of any part of the disc against the spinal nerves. But on the right hand side, we've got what we call a slip disc or a prolapse disc, where part of the disc is bulging now and adding pressure to the spinal nerve, and that's what causes the pain. And this is why we need to be careful with our spine when we're undertaking manual handling. We've got to keep that spine as close to straight as possible, its natural position, whenever we're lifting, carrying, pushing or pulling. Now, the Health and Safety Executive do give guidelines on lifting and lowering, but in my view this is to do with the average person. Woman on the left, man on the right. We are not all average, we are all different, we're not all cast from the same mould. So, although these weights are guidelines, almost a code, I wouldn't put them down in tablets of stone, because I say we are all different. Manual handling. Now, there are 4 things we need to consider when making a manual handling risk assessment, and it's worth remembering these 4 areas for the exam. Now, I always put them down as light. Now, you might have been on a manual handling training course where they put it down as tile, which doesn't make a lot of sense to me, but light does, because if possible, you're going to try to make the object lighter if possible, to actually carry it or manual handling. So, what do you think light stands for? What does L stand for? What do we consider first? Well, we actually consider the load. I, what do you think I stands for? Or, more to the point, who does I stand for? It's the individual. T, what are we actually going to do? That is the task. And where are we going to undertake the task? Yes, we need to look at the environmental factors. So remember that, L-I-T-E, light, load, individual, task and environment. And in a bit more detail, the load, for example, we need to consider the size, the weight, stability and grip control, if there are any. What about other hazards? And with all these, we might have to provide PPE, personal protective equipment. The individual, are they suitable? Have they received information and training? What are the perception levels like? What is the task? Are we lifting, carrying, pushing, pulling? Let's have a look at the equipment design. Try to avoid repetition, minimize distance, do it in separate movements, for example. And the environment, maintain safety, make sure there's no obstructions. If there are, move them, plan the route first. Provide equipment such as PPE and other facilities.